Working on Leetcode 322. It's a question that is called coin change. This is a notorious coding interview question. You can see here that it's asked by Goldman Sachs 20 times in the last 6 months, Amazon, Bloomberg. It's definitely one you want to know, and you want to know it well. It's a dynamic programming problem, and it uses a method called tabulation. That's how we solve this. When you see a problem like this, you want to think dynamic programming and tabulation. If you're not familiar with tabulation, highly recommend to do a deep dive into it. These types of questions will become a lot easier and make a lot more sense. So let's take a look at the prompt here. You're given coins of different denominations and a total money amount. Write a function that compute the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have an infinite number of each kind of coin. Okay, so we got coins 1, 2, and 5, and an amount of 11. So the output is 3. We can do 2 5 coins, one $1 coin, and that gets us 11. That's the minimum amount of coins we need to get to our target amount. Example 2, we have a $2 coin, and we have an amount of 3. It's impossible. There's no way you can have any combination of $2 coins to get to 3. Example 3, we have a $1 coin and an amount of 0. That is 0. You can do that just with 0 coins. You can get to that amount with the denomination of coins that are given in the input. Example 4, we have $1 coin and an amount of 1. That's 1. And number 5, similarly, we have a $1 coin, we have an amount of 2, so 2 $1 coins gets us 2. Okay, so like I said, this is a question that we want to use a method called tabulation. All right, so here we have our coins. Okay, and we have a $1, a $2, and a $5 coin, and we have an amount of 11. So what we want to do is we got to create a table that represents all the different amounts that we can have and how many coins it will take to get to that amount. And then we want to keep a running tab of that, and as we iterate through these different denominations, we want to check what is the minimum value. We want to update it as we go through these different denominations. Okay, so I'll kind of go over here. Anytime you see tabulation, you want to usually think of an array and iteration. So here we have our amount. This is basically what we're going to base our table off of, and we just want to do we want to create an array that is basically all the different amounts that can possibly arise from this total amount. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so we have an array of length 11. And what we want to do here is we want to keep a running table of this. So I'm going to just label this as amount. And what we're going to have on the top, or the values in this array, is we're going to have our coins. How many coins does it take to get to that amount? Okay, so we'll have coins. And what we're doing in the value here is it's not the coins itself, it's how many coins, whether it's 1, 2, or 5, or a combination of those. How many of those coins does it take to get to the amount, which is the index that we're labeling it as? Okay, so if we're dealing with 0, how many coins is it going to take to get to an amount of 0? Well, we don't have to do anything. We can preset that. We can already set that as 0. Okay. Now, for a $1 coin, it's just going to be the amount. It's going to equal the amount is how many coins it's going to take, because it's just $1. So $1 is going to, for the amount of 1, it's going to take one $1 coin. For the amount of 2, it's going to take two $2 coin, or 2 $1 coins, 3 $1 coins, 4 $1 coins, and so forth. Okay, now what we're going to do, so we're iterating over this. Now we're going to come here to this $2 coin, and this is where we have to do some comparisons. So what we want to do is we want to check, is the coin, okay, is the coin, is it less than or equal to the amount? Okay, now why is this? Why do we want to check if it's less than or equal to? Well, if the coin is more than the amount, then it doesn't equal the amount. It can't equal the amount. It's very similar to this example here, where if the coin is 2 and the amount is 3, there's no way we can get this $2 coin to equal 3. Okay, so likewise, we want to check, is the coin less than or equal to the amount? Okay, now if we do find that it is less than or equal to the amount, then we've got to check the table and we got to see what is the minimum value and update it accordingly. Is the current value that we have going to be less, or is the value that's already in the table going to be less? Okay, so what we want to do here is we want to do amount minus the coin, and this gives us our index. Okay, we want to check whatever that value is, check the index of that in our table. So for example, if we get to 2 here, is 2 less than or equal to 1? Or I'm sorry, is 2 less than or equal to 0? No, 2 is not less than 0. Is 2 less than 1? No, 2 is not less than 1. Is 2 less than or equal to 2? Yes, 2 is less than or equal to 2. So what we're going to do here is we're going to take the amount, which is 2, and we're going to minus it from the coin, and that'll give us a value here which we're going to label as our index. Okay, this will be 0. And what we want to do now is we want to create a potential amount. We want to check, we have a value here in coins too, but can we come up with something better? That's what we're checking here. So we're going to check at the index of 0, we're going to have 0, and then we're going to add 1. Okay, so what we're going to do here is we're going to do table of IDX plus 1 is going to equal our potential amount. You know, I'll call this so I have a little bit more room here. This will be our potential amount. Okay. Now we want to check this potential amount, which is table IDX plus 1, which is going to equal 1. Because let's take a look here. Our table at IDX, when we're checking on 2, okay, 2, which is the amount, minus the coin, which is 2, is 0. That's our IDX. We're going to check this 0. That value is 0, and then we're going to add 1 for the new coin that we're checking. That's going to be our potential amount, which is going to equal to 1. Now what we want to do is at that element of the table, this current element of our table, we want to update it. We want to check, and let me just go ahead and make a little bit more room here. Okay, we want to update our table. We want to check table at our current index is going to equal the minimum of our current, whatever is in the current index of that table, so table at I, or the potential amount. Okay? And that's the code. When we do this and we go over the entire iteration, the entire loop, what we're going to end up is our last element will be the correct amount. Okay? So let's go ahead and code this up. I think it'll make a little more sense once we get to the code. Okay, so here we have coin change, and what we want to do is first create our table. Okay, so we want to do const table, and we're going to go ahead and create a new array. Okay, and that's going to be amount amount plus 1. Remember, we want to add the extra 1 because we want to take in for the 0th index. Okay, and then we're going to do a dot fill, and we're just going to fill it with infinity. And the reason we're doing that is because we're doing this minimum comparison, the minimum here, the infinity amount will basically defer to whatever is in here. No matter how high that number is, it will always give us the right value. So that's why we use infinity. It just makes things a little bit easier. Okay, and now what we want to do is, remember, anytime we're dealing with tabulation, we want to make sure we fill in that first element of the table. Okay, so we're going to go ahead and fill in the 0th index at 0 is going to equal 0. Table at 0 is going to equal 0. Now what we want to do is want to iterate over the coins. So for let coin of coins. Okay, so that now we are going to go over each one of our coins here, or 1, 2, and 5. And now we want to compare that to our table. So our table amount. So we can do for let I equals 0, I is less than table.length, I plus plus. Okay, and remember, I represents the amount. It's the index, that's the amount. And so now what we want to do is we want to check if the coin that we're currently on, which is, you know, the first pass would be 1, is it less than or equal to I, because we're using the indices as the amount. Now, if it is, then what we want to do is we want to get the potential amount. Okay, so we want to say let idx equal I minus coin. That's going to get our index, and then let our potential amount equal table at idx plus 1. Okay, and now all we have to do is update the current iteration of where we are in table. So table at index I is going to equal math.min of potential amount compared to what is currently at that index in the table. Again, that's why we use infinity, because if it's our first pass around, and you know, our current in whatever's current in the table will be infinity, so it'll automatically defer to that potential amount. Okay, and so now we just want to return, and you know, if there's nothing in there, then it will stay at infinity. So we can do table if table.length, the last element of the table, if it equals infinity, then we can assume that it was not found. Else we just return table at table dot length minus 1. Okay, go ahead and run that, and we're good. Okay, and so this can be a bit of a tricky one, but once you kind of understand this concept of tabulation, it really does get a lot more clear on how to solve these types of problems. And again, this pattern of tabulation comes up a lot. It's in dynamic, it's all over the place in dynamic programming. It's also Fibonacci. There's a way to use it in Fibonacci, getting the Fibonacci number, that's pretty effective, and it's a good way to kind of conceptually understand it if you're still having trouble getting your head around this one. So anyway, that is coin change 322. Hope you enjoyed it, and I'll see you on the next one.